Olá, boa noite a todos. Meu nome é Luiz Felipe Ribeiro, eu sou professor, colaborador e pesquisador em computação visual do Instituto Terce e esse é o nosso evento piloto da Semana da Computação Visual. Hoje a gente começou a inaugurar, a gente teve anteriormente uma conversa, uma apresentação de uma tech que foi a Bemob, uma grande tech da área de distribuição de apps e games, e agora a gente vai contar com a presença do pessoal da Fugro, que é uma grande empresa, uma empresa multinacional de geociências, de um modo geral, sensoriamento remoto, fazendo uma apresentação muito bacana, focada em Machine Learning, a parte também de sensoriamento remoto, e algumas coisas que, principalmente alunos de NCG 040, Introdução à Visão Computacional, viram já comigo na minha disciplina. Então, é um prazer enorme trazer essas pessoas aqui hoje, tá? A palestra, só avisando para o pessoal, a palestra será em inglês, não sei se ao vivo o YouTube consegue fazer o closed caption, e a tradução automática, mas quem tiver alguma dificuldade com o idioma inglês, depois é só assistir novamente, tá? Mas eu peço, assim, quem puder acompanhar, a gente sempre, quando possível, vai tentar traduzir alguma coisa, ou colocar em algum contexto. E vou começar a chamar aqui nossos convidados da Fugro. Primeiro, Mariana Ferraz, aqui do Brasil, time Brasil da Fugro, de inovação. Boa tarde, Mariana.
Boa tarde, Luiz. Tudo bom? Obrigada. É um prazer muito grande para a Fugro participar aqui. É um prazer muito grande para mim também, em especial, estar aqui dentro de um evento da FRJ participando com vocês.
Muito obrigado. E eu que agradeço a sua presença aqui. Agora eu vou chamar em inglês. Like to introduce you, Andrea from Fugro.
Hi.
Hello.
Hello. Hi. Nice to meet you. It's a pleasure to be here with you this afternoon and to present what we're doing in Fugro.
Thank you. It's my pleasure to have you guys here with us. So now I'm gonna leave the presentation with Mariana and Andrea to give a little pitch about Fugro and Fugro offerings and how what Fugro does around the world, including Brazil, I guess, or at least I think it is all over the world. Fugro, it's a huge company. So I'll leave it to you guys. So have fun, and see you later.
See you later.
Thanks. Have fun. It's the heart of keeping innovative, right? So that's a good catch. Having fun, it's part of what makes us continue. I will say a short thing in Portuguese, then I will flip back to English. Eu sei que a maioria de vocês vai entender super bem a apresentação, mas se alguém quiser fazer alguma pergunta e não se sentir confortável para fazê-la em inglês, pode fazer em português, tanto eu quanto o Luiz. A gente ajuda fazendo a tradução para o Andrea, então, responder. Okay, so feel free. You can ask in English, you can ask in Portuguese. We'll support this and move ahead. I will introduce myself, and I will let later Andrea introduce him, because he's an amazing professional. So I'll just speak a little bit about me. I was a student at the Federal University and an intern at NCE, so it's a huge pleasure to be here indeed. I joined Fugro 3 years ago, and I fell in love with this company. Why? What's Fugro? Fugro is a huge company, as Felipe said. It's a geodata company, and our goal is to deliver excellence. So we deliver analysis, we deliver data, we deliver sample, always with the reference of where and when, and looking the best way to do so, looking for the fast way to do so, for the more accurate way to do so, or to the safest way to do so. It's our goal. It's what keeps us pushing ahead. So we continuously look for automation, we continuously look for innovation. And that's why we have inside of Fugro such a huge group that focus on innovation, okay? We deliver innovation internally to improve our own process, but also to our clients to deliver better solutions, better products to them straight. And it's on the top of that we work on a daily basis. As Felipe mentioned, Fugro is a global company. We have 3 major innovation groups, one in Americas, one in Europe, one in Asia and Pacific. We also have operations that with clients happening in 61 countries across the globe. And we have today probably a little bit more than 9,000 employees. So those are the numbers that shows what's Fugro. I would like to invite you to take a look at our webpage, fugro.com. Has a lot of information there about the company, about the solutions we deliver. And you also find about the solution that we'll show to you today, that it's a little bit of our work. It's an amazing project, an amazing work. It's developed by the team that Andrea today leads. Okay, and I, with that, pass the word to him to introduce himself and introduce a little bit and show this amazing work that they deliver to Fugro and to the globe. And you are on mute.
Yes. Hi. Yeah, thank you, Mariana. So just a little bit about my background. I graduated in 2014, University of Bologna. I'm originally from Italy. And I've been working for Fugro for 5 years. We do some amazing things. I totally agree with Mariana. We are working a lot in the innovation to try to deliver a state-of-art technology, but also to solve problems that are really challenging. I started in Fugro in the Netherlands, working for the rail department. Also there is a really big innovation department. And then I moved to Canada, and I'm currently located in Vancouver, and I'm working remotely for the Road Innovation Department in Mississauga in Toronto. So we are specialized in acquiring data in the road environment, in the road business. So I can share some slides that I prepared today. Okay. Can you see my screen? Is it visible on my screen? Can you see?
Yes.
Okay. Yeah, so I will talk a bit about the development that we have been doing. So I'm the team leader of the Road Innovation Department, specifically to road automation. What does it mean, road automation? It's basically we collect the data, and then my responsibility and of my team is to process the data automatically using machine learning or using other type of algorithms to try to reduce the manual intervention that is normally done by the user. So we have a really big data processing team in Fugro, Canada, that are processing the data that we collect in the road. We want to try to reduce that time that is done by manually as much as possible in order to speed up development and to make sure that we can deliver fast to the client and that we can make the client happy. So I will, this is the agenda that I prepared for today. I will briefly talk about Fugro Roadware, and then I will talk about a couple of projects that we work on. Some of those projects is computer vision and deep learning. Other project is specifically deep learning, and then there is the last project that is only computer vision. Fugro Roadware was founded in 1979. As I mentioned earlier, we are driving around with a vehicle that is equipped with a lot of sensors, a lot of like some really state-of-art sensors like a laser scanner, IMUs, cameras, and we collect data of the road, not only to analyze the pavement condition, for example, if there are cracks, potholes, or other distress in the road, but we also analyze and extract the data that are around, so the surrounding. That means objects in the surroundings. We georeference those objects, traffic signal, traffic sign, and we want to deliver those information to the customer. So we collect the data and we deliver a report with the condition of those assets or the condition of the pavement of the road. So we don't really fix the data, we don't fix the road ourselves, we only survey and we deliver the data. So we have this is one of our vehicles. It is called automatic road analyzer. It is equipped with a lot of sensor, and the idea is that using like a multiple system, we are continuously measuring the road, and then we don't need to. We can keep driving around without really stopping, and we can drive at the 100 km/h, so that it will allow to do like faster survey without interrupting, for example, the flow of the road, or without stopping the traffic. After that, we collect the data, we analyze the data, and then we present it to the customer. And we normally sell this product to like at the state level, for example, at the state of California, or at the municipality level as well. But because of the high quality data, normally we partner most likely with the bigger municipality or state level again, because they have a bit more budget, and because it is really important for them to keep the road at a really high level standard. For example, interstate road, where the speed is really high and you cannot have road that are full of cracks, otherwise it will lead crash, and it will lead other issues. I'm going to talk a bit about the sensor that we have in our vehicles. So typically our standard vehicles we have like 3 cameras mounted in the front. Those are high resolution camera, which they automatically change the settings depending of the exposure. So we don't really change manually the exposure, but they're called broadcast camera, normally are used in the film industry, and they automatically compensate depending of the lighting condition. So they're really special camera, really expensive, and to deliver really high quality data. Inside this area, this vehicle, there is an IMU and a GPS. Also, they are really accurate GPS, because as Mariana mentioned, we are the leading geodata company all around the world, and our customer, they want to have reliable position of the asset and of the condition of the pavement in a specific location in the world. So we really need to have really high accuracy, really high accurate IMU and GPS. Then we have at the back of the vehicle a system that is collecting the pavement. So while we're driving, we're collecting data, and move all this data in an image. We're actually collecting those images, and then we're storing those information on the hard drive. We're using 2 different sensors. One is called Pave2D and is using a stereoscopic imaging measurement system. So we have 2 cameras, and then we have one LED, one light that has been illuminating one line, and then we're actually capturing the specific line, and we concatenate the lines to make one full resolution image. The other sensor is similar, but it's a little bit different system. We're using laser. Also in this case, we have 2 cameras, left and right, but we're using laser, so it is a different technology. Also in this case, as in the other one, we can collect data in the night, because there is this laser that is illuminating the line, so we're not really constrained by the light condition. For example, if there is too much sun, if there's cloud, it's always collecting data at the constant quality. So we collect the data line by line, and then we combine the line one after each other, and we are able to understand at the millimeter level how is the condition of the road. That's why we have such a complex system, and you cannot do that using a standard camera. You need something, specific device that is really lighting and illuminating and collecting in a specific location at really high accuracy. After that, we have one image, because as I mentioned, we have 2 sensors, one on the left, one on the right at the back. We can actually create the depth, and we can do, and we also have the point cloud. So when we have the point cloud, we actually have all the information of the crack. So in every single at every single location, we can go back and look at the image that we capture and see, okay, there is a crack, there is no crack. And we can see all the depth, as you can see at the bottom in the right side of the screen. So the first project that I'm going to talk about is called crack detection. This one was a bit of an introduction of what we're doing in Roadware. The next phase is going to be talking about crack detection, which is one of our most important projects. Basically, we have an application that is able to show the data that we collected to the customer. So as you can see in the middle of the screen, there's an image, and that image is an image of the pavement. And then there are some drawings. Those drawings normally are done manually. So the user is going to draw where there is a crack in the pavement. But because of it is really time-intensive and time-consuming task, we wanted to automate it. So we tried to think, okay, what is the best way to automate this step? And we talked about machine learning, because the condition of the pavement are different depending on the type of asphalt. So you have some cracks that are going to be visible in certain type of asphalt, but not in the other one. But we need to find a unique way of annotating cracks that were independent by the pavement condition and were also independent by the user. For example, I can see a crack, but another user that is a bit more expert can say, okay, this is not a crack. For example, if you can see in this side of the image, there is a tiny bit crack, but it's not as severe and it doesn't need to be annotated. So we talked about machine learning, and then we start to look what are the best way to do that, to solve this task. Initially, we were thinking about UNet, and then actually we end up in implementing a variation of UNet, which is called attention UNet, that is gonna activate only some specific node in your neural network, which are gonna be the most important node, and where actually there is a specific feature in the image. So in this way, we actually is an advance, is actually an improvement of the UNet, and the reason is because it's actually faster. So it's faster because it's gonna only the most important part of the convolutional network are activated, and only those are the ones that are really important in your image, and you want to extract the specific information from your image. At the end, we decided to go for this implementation, and we implemented our pipeline. So we start with the full resolution image. Full resolution image that is a 7K by 4K, so it's a really high quality picture. So we had to divide this image in small tiles because it didn't fit in the machine learning in the GPU. And then we started training. So we do the training in Python and in PyTorch. We run the training with SageMaker or in one EC2 instance. And then when the training has been done, we upload the model in MLflow. MLflow is an application that helps you to track the improvement of your model over time. So if you keep training your model, you can see what are the best, how the value are changing, and how they improve over time. So you can decide what is the best model that you want to use in production. After that, the model will be stored in S3, and then from S3 we have a pipeline that is our build server is taking the model and is combining the model in a Docker container, and is actually building the application and is building the installer. So in the final application is a desktop application, and it's going to run in the computer of the user, and there is already the model. So because we didn't want to access to the cloud, we wanted to embed the model in the application itself. That was the only way to do it. So this pipeline is actually explaining the training and the deployment. Then when we go to the inference, we take the image full solution, we divide it in tile, and then we take the model that is already embedded in the application, in the installer, in the executable. We run the code, and because the application has been written in C++, we use PyTorch, C#, and then we do inference, and we store the result in a database. Those results are stored as a coordinate. So basically, we have now in the database the coordinate and the information where the crack it appears in the image, so that we can retrieve this information after when you want to run the application. So after that you've done detection, you just open the application, then you can scroll image by image, and you can see your results that have been previously stored in a database. But you don't need to do again detection, you can just pull it from the database. So this one is a full resolution depth information of the road, and these one are the result of the machine learning model. And as you can see, it's a binary mask, and the final result, it is this one. So you have the image that has been detected, and then at the top of the image, there are those cracks that have been detected automatically with the machine learning model. And for every single image, we have how many cracks we have. Then we have also if it is longitudinal crack, transversal, alligator, and how large is the crack, what is the width of the crack. So that is the crack detection project. Next project that I'm going to talk about is called payment type classification. So because we collected the image of the payment, we also want to find out which type of payment is it. In this case, it's different. It's not a segmentation task, so we don't use deep learning for a segmentation type of algorithm, but we're using classification. So we want to find out that type of payment belong to this class or the other class. It is again a deep learning algorithm, and we want to find out if it is concrete, if it is asphalt, or if it is brick. And then within those categories, there are also some subcategories. For example, if it is a specific type of concrete, which has the name of joint concrete pavement, if it is a specific type of asphalt, for example, flex or composite, or chip seal. We use a wavelet convolution neural network. In this case, it's a bit simpler network, and it is also state-of-art architecture. And yeah, so basically in this task, we want to recognize the texture of the pavement and then classify it. We immediately find out that it was actually a pretty challenging task, and it was not really easy for the machine learning model to generalize. And the reason is because also for human eyes, it's really difficult to understand the type of pavement. So we had to change a little bit the scope and actually deciding to build a multi-stage classifier. So you take the input data, you do the first classification, asphalt, brick, and concrete, and then you do a further classification depending on which kind of class you want to recognize. So if it is asphalt, then okay, we train another model to do detection and classification if it is a flex, composite, or chip seal. And if it is concrete, we actually differentiate between GCP and CRC. Also, this model has been deployed in production. This is the pipeline, how it looks like. Is slightly similar to the pipeline that we had before. And we're just using different type of algorithm, but it's really similar. And that is the inference part. Again, it looks pretty similar to the pipeline that we saw for the crack detection. That is the final result with the algorithm that has been run. So we run the algorithm normally section by section. So we take a section that we collect on the road, and then we run the algorithm in all these sections. And then for every section, we can say, okay, these 200 kilometers belong to asphalt. This one belongs to concrete. And then we can see the result at the bottom of the screen, where a really long piece of road is being classified as a portrait.
I think.
Tá cortando para você também, né?
Yeah,
Andrea,
I think it's having
it
some
started to cut
audio.
out. Yeah, it started to cut
audio.
off a lot. We can't hear you.
Yeah.
No, there is a noise behind it. It's just not passing through. We can't hear your voice clearly.
Yeah, probably some issue with microphone. I don't know.
Okay, so everything is good.
Oh, now
back.
It's okay.
Did you hear me? Can you hear me?
Yes.
Okay, there was a bit of interruption or no? Okay, I will continue with the presentation. The next project is called pothole detection. So also in this case, we want to identify if there are some potholes in the road. And also this project was actually pretty challenging. And the reason is because the internal data set that has been pre-annotated sometimes is not consistent. So it was not really easy to understand whether a pothole was actually a type of feature that we want to integrate in our data set. And because if it's not the right type of feature, we don't want to teach the model to understand the incorrect type of pothole. So it was not a challenging project that we also we moved to production, but it was pretty interesting also because there are not a lot of available data set that we could have used for training these models. So we had to internally manually annotating potholes, but also the difficulty was to differentiate between which one was real potholes and which one was mistake that was annotated incorrectly by the user. Next project is called asset extraction. So it is a little bit different. We're changing domain now. We're looking at the camera mounted in the front of the vehicle. So what you see here is an image from one of our software called iVision 5. In this application, we can see an image of the road, and we want to identify if there are some traffic signs that the customer is interested in. So what we did also in this case, we want to reduce as much as possible the manual annotation of this type of asset, and we developed a machine learning computer vision solution to automatically detect sign, traffic signal, traffic beacons, and those type of objects. One of the challenges that we had was that normally the same feature would appear in multiple frames. So we need to train the model, and also we need to implement a specific solution that was actually aggregating data. And it's not really easy because you don't want to detect, you want to have the best shot. So the image needs to be as good as possible, but you also don't want to have too many detections because then it's going to be difficult to filter the data. So we have to look at some kind of tracking algorithm where we detect the feature, we identify that is the same feature, and we assign the same ID. So we implement a tracking algorithm, and that is how it looks like the final solution. So you can see that even if the vehicle is changing line and is moving to one side to the other one, is able to assign the same ID. So the algorithm is able to assign the same ID to the same traffic sign in this case. As you can see in the middle, there is a sign, and even if it's moving, we're keeping assigning the same ID. That was not a successful project, which helped a lot, again, the internal user, the internal data processing team, to speed up the delivery of a project. So also in this case, the goal was actually to help them to save time. The last project that I'm going to talk about is called shoulder camera image projection. This is only a computer vision project. We didn't use deep learning, but the challenge that we had here was that we had the camera mounted at the back of the vehicle. As you can see in the middle of it's like a camera that is facing down. So it is a normal camera, a GIG camera, and we wanted to change the perspective of this camera if the picture was taken from the top. So we have to apply image projection. So we have to project the image from one plane to a different plane. But in order to do that, you need to identify the intrinsic and extrinsic camera calibration. When I'm talking about extrinsic, is the orientation of the camera with respect to the IMU. Because if you shot a picture in one specific location, you need to understand how the camera is being oriented. And if the camera along the way is moving, we need to understand that. So that was not a challenging task. And the final result will be that you have two images projected, which are the images that you see in the middle of the screen, gray. Two images that are next to each other, but they've been collected in a different perspective. But if you concatenate one after each other, they look at that being consecutive images, and they look if the camera was mounted at the top. In addition, we can also measure the length of the object, how big is the object, and every single feature that are in in the picture, we can measure it and deliver to a customer really accurate data. It was a bit of a difficult project, let's say, because we didn't have so much experience in this domain. And, and furthermore, there's also the calibration issue. And because we had to calibrate internally outside the camera, was a quite challenging task. Again, this is the final result. So you have like 2 images, actually 3, and they look consecutive, one after each other. And you can view it from the same application that I showed you before. That is pretty much it that I have. I hope you were able to hear me correctly.
Yes, was great. Now everybody knows why I admire your work so much. It was a great presentation, Andrea.
Thank you so much.
Yeah, I would like to add that this was a great presentation. So much technology into a same project. It's incredible. I can't tell. You told about like in one presentation you got into many topics of a full semester. Like you had tenho, UNet, you had deep learning, machine learning, you had computer vision with dot grid calibration and all sorts of things that typically we go through like 1 or 2 full semesters. So it's incredible. It's amazing to see that. Very, very, very cool. Probably I will open now for questions from the audience. So I will switch just to Portuguese a little bit. Pessoal, agora a gente vai iniciar a rodada de perguntas. Quem tiver alguma pergunta para fazer para o pessoal da Fugro, ou a Mariana, ou o André, a hora é agora, pode escrever em português. A gente dá um jeito aqui de traduzir da melhor forma possível. Mas enquanto vocês fazem a pergunta, eu vou fazer uma, né? Andrea, while the students are thinking about questions, I will have one to actually make. In the process of, say, building a model, for example, for a road extraction, you have so much different models and approaches to when it comes to road. Like you said, the multi-classification tasks you had for the type of asphalt, and you also have some labeled data sets for pothole detection. You also have mixed approaches to models in terms of training a new data set. And considering this, how do you generally, you guys at Fugro does when tackling a new problem, like a course of action to select approach or at least a neural network architecture? For example, you use attention UNet, and the other one was wavelet. That's right. So in this process, how you guys handle what is the best approach or the neural network architecture for a specific case?
Yeah, so it's really important to understand the type of data. So the first thing is to understand the data set. It really depends on the project. For example, in case of classification, if you want to do like a texture classification, we try to understand what is the best model out there, like reading and analyzing different papers. So we go through the paper and then we see, okay, this one, it is being used in multiple projects and it is successful, and it gives us, it delivered this accuracy. Then we test it with our data. If it's not successful, we change one, and then we go for different architecture. For semantic segmentation, yeah, like UNet, it was a little bit different. So we already know that we wanted to go for UNet, and the reason is because we wanted to use as less data as possible for training the models, and sometimes you need to have huge amount of data. So one of the advantages of UNet is that it didn't require so much data. Another advantage is that it was quite efficient. But we initially started with UNet in 2019, but then we saw that in the literature there were a lot of other models that were developed later on after UNet. So there were like actually some improvement of UNet, and there were at least other 10 or 15 papers. So we tried to use at least 5 different models. There was UNet++, attention UNet, there was like a res UNet, and the only way to find out which is the best one, depending of your type of data, is to try all of them. So we try to train with one, we try to train with the other one, try to train with the next one, and then we do the inference and we do the comparison. And then you have all these metrics that you can use to compare the accuracy. You can do for a specific, for semantic segmentation, you're looking at a Jacquard metric, or you're looking at you don't really use intersection of a unit, you're looking at different metrics. And the reason is because intersection of a unit is more suitable for object detection. So mostly Jacquard or the dice coefficient. Yeah, so just we need so you need to read a bit the literature and then try with your own data and see what is the best one.
Excellent. Thank you very much for sharing this. I will pass to the questions from the students. Pedro is asking, this seems to be a pretty expensive hardware. Could you share us a bit of the challenge you face acquiring of or developing such type of hardware?
Yeah, so the hardware indeed is really expensive, and that's why normally our customer our customer where they have like really a lot of budgets. For example, state of California or state of New York, we can't really offer this service to small municipality. But what it is expensive. I can't really tell you how much. I think it's about 600 or 800. But you can also, what we are doing in my department, we're actually we're only working with the data that we collected. For example, instead to use the images for such expensive vehicle, you can also collect the images from a GoPro or even like a different camera mounted at the top of your vehicle, and then you only process the image using that information. So the complete system is expensive, yes, but if you extract and if you take out all those single components, you can actually use those components in a way less expensive vehicle, and you can do a different type of analysis, but you can apply the same machine learning, and you can apply the same algorithm, and you can offer a slightly less accurate survey to, for example, customer that they don't have such a huge budget to invest. It really depends on the requirement. So if the customer wants really, really high quality data, or if it is okay with a little bit lower resolution data, where we can actually create a vehicle less expensive. And for example, we're working recently in a state of proof of concept that you can do detection of the cracks also without using laser scanner, with just one camera mounted in the front of the vehicle. Super low, yeah, so like low cost. Yeah, and the challenge that for acquiring and developing this big vehicle, yes, there are a lot of challenge. I'm not really responsible for the acquiring the data in the vehicle, so there is a specific team for that where it's working with embedded system, and there's a lot of issues with synchronization because everything needs to be synchronized and timed correctly. So, for example, the camera, they need to be synchronized with the GPS, the laser, they need to be synchronized with GPS, and sometimes the hardware, they don't communicate really well with each other. For example, I was talking at the beginning about those broadcast cameras that are mounted in the front. Those are specifically for recording movies, and they're not really designed for acquiring data with that is really time sensitive. So we're actually moving to a different type of camera. They're still really, really expensive, but they're gonna be a bit more reliable for the timing. And it is important because when you want to calibrate your vehicle, everything needs to be in sync. And if it's not in sync, the data that you deliver, when you georeference the data, they're not really accurate.
Excellent. Well, let's see. Next question here from another Pedro. It's another Pedro. One is Pedro Gomez. The other is Pedro Correa. Amazing. This project of pavement classification is important for quality control of roads and highways.
Yeah. So it is indeed used for. I mean, it is used for any kind of road, but it is used specifically for quality control of the road and detecting the type of pavement. And the reason is because if the customer need to go there out and for example make some changes in the road, you need to know exactly which road has which specific asphalt, and then you can also correlate the data. For example, if you have some cracks in the asphalt or if you have some crack in the concrete, you might need to take different assumptions. For example, if they are in the concrete, it might be that the foundation of the road are not really correct, and you need to think about, okay, maybe I should change something. We did also a project in California where we need to analyze the bridges and the bridges condition, if there were some cracks on the bridge, because if there are some cracks on the bridges, it can be a bit more scary. So it is really, everything is about quality of the data, and we want to make, one of our values is actually making the world safer and more, safer and also more sustainable. So there are a lot of projects also in different departments where we're moving in that direction. So quality is really important.
Excellent. Well, let me see if I have another question here from the audience. We still have a few minutes left. Let me see here. No. Any questions? Okay, understood. Okay. Well, actually, I have one more question for you. So, let's just see if the students make another question. But okay, I'm going into another question. Based on the previous question about the models, the choice of models. And in the same fashion as the hardware, sometimes depending on the requirements, you answer that depending on the requirement, we should go low cost with software or with hardware, for example. But I think somehow it's the same thing but in terms of computational costs for some machine learning deployments or tasks be it for training or inference in terms of because it's you collect a huge data set. I've seen for that it's a high resolution. You split into tiles to fit into the model, into the training process. But there is some application that you can that you guys need to go like real time in terms of inference or try to the training process be as fast as you can. Like you use you build your models from scratch or for example, in the terms of building the model, you guys build the model from scratch or you have some sort of model zoo that you constantly update and probably do transfer learning in it. And for inference, if you have some cases that you might want to have real time or at least near real time inference, and which cases are that?
Yeah. So we don't have a lot of real-time requirements for now. I think it's something that we're looking maybe next year to try to do real-time processing. At the moment, all those tasks and jobs are run in post-processing. They run, some of them, we run it directly in the computer of the user using the GPU, or in other cases, we're actually running in the cloud. That is about inferencing. Training, all the training is happening in the cloud, and we are using, depending on the project, some project we're training from scratch. For example, UNET, we're training from scratch using our own data. But then other projects like that I didn't show here, do object detection with YOLO or mask CNN. For example, we actually use a pre-trained model and then we fine-tune it. For detection, for inference at the moment, yeah, it really requires a lot of GPU. I think it is super cool actually to start to think about developing on the edge. It's only about what are the priorities. Sometimes the priority are not really okay, go faster, but try to detect after collection, not really on the vehicle, but you can do it the day after in the cloud. And in the cloud, you have way more processing power, so you can do parallel processing of multiple images at the same time, and at the end it's going to be faster. Yeah.
Oh, okay. Thank you for that. And of course, 2 more questions. I will add 2 more questions because
Sure.
I think the audience want. Let me see. Oh, Thales. Thales just asked a question. Then I will give priority to my students. But then to wrap up, just remember I have actually one little question about models. It's a curiosity, but let's see the question from Thales. Great talk. How to establish this trade-off between great accuracy and fast response from the model at these examples you gave?
Yeah, it is a good question. So yeah, thank you for the question. So it is always like so when you're talking about like fast response, if I understand correctly, you're talking about the how fast you're going to do detection. So at the moment, it's not really important for us to do fast detection. We actually we want to do, especially for the project that I show you now, we rather have higher accuracy than faster detection. And the reason is because we run everything in the cloud. So we run all these processing job in the cloud, so we can actually leverage and scale horizontally, and we can keep processing the data. And we can actually spin a lot of machine at the same time to run inference in every single image, but we rather go with high accuracy. In the future, maybe if we're looking more at object detection type of project, which we developed a proof of concept recently, and if you want to do detection in the vehicle on the edge, then you want to find the right trade-off, and you want to find good accuracy but also really fast, in order that we don't need that we have enough time to do inference in the vehicle, in a small device, in a small when I'm talking about small device, I'm referring to without having so much computational power, because on the edge you can run, you don't have the same power compared to an NVIDIA GPU of 12 gigabytes. I think you're muted.
Oh, yeah. Now I'm muted. Thank you for that, Andrea. Just to wrap up, just a last question, I think in connection with the previous one, the previous ones. What is the most difficult thing? Of course, you don't need speed, so there's no trade-off between accuracy and some other regards. But there's one thing that I'm wondering: what is the worst case scenario for you guys in terms of false positives or false negatives? Which one are worse for your application, and how you mitigate false positives or false negatives via tuning of hyperparameters and so on?
Yeah, so it is another really nice question. So, for example, in the project that I show you about asset extraction, we want to extract traffic signal or traffic sign or traffic control, all those specific objects. And it is more important for us to over-detect than missing a traffic sign. And the reason is because after, our goal is to reduce the time that manually a person is looking at every single image. So if we over-detect, yes, we actually provide a couple of more data to review to the user. So the user will still review the data, but we actually don't miss object that to deliver to the customer. If we are actually missing an object, it's going to be an issue because the customer say, okay, there was traffic sign there, but it's not been detected. So we prefer like a false negative than like missing an object. And if you miss an object, it's going to be a false positive. So yeah, so that is the trade-off. I don't know if I answered correctly. Is there anything else that I missed? Your question?
No, actually, you already answered. I'm okay with this answer. It's in the line what I was expecting for object detection. Is normally the most cumbersome part of detection, and that we need to mitigate for false positives, and it's along these lines. But I was talking to you. I was saying about which parameters, but
yeah. No,
yeah,
that is
you tend to.
Yeah, so normally when we try to tune the hyperparameters, and normally there are only, I mean, you don't want to spend too much time in tuning those hyperparameters, but ideally you want to look at, for example, the learning rate. You want to decrease or increase the batch, normally the batch size. You want to, those are the parameters. Just sometimes you want to use a different, so those are a bit, maybe sometimes when you see that you don't have really high accuracy in the detection, it might be that all the models are also not correct, or the data is not really correct.
Exactly.
And sometimes we also notice in our case that the pre-labeled data was actually incorrectly labeled. So, or another factor is that sometimes the model tries to generalize, but sometimes is also detecting some traffic signal, for example, that they actually they're not part of the traffic signal data set, but maybe was a sign that was placed there by someone, and it's not really belonging to the traffic sign data set of the state, for example. But yeah, those are the hyperparameter. Learning rate, batch normalization. Yeah, those are a bit the parameter. I don't recall that.
Yeah, actually, for the labeling, I have a better example of this. In one project, I went lazy and got to Amazon Mechanical Turk to label the images, but I wouldn't want to expand much, and my data set was like a mess, and I compiled the model, and it was a model for personal protective equipment in a factory setting. But what happened later, when we deployed the edge device on the plant floor, it identified bald people as wearing hard hats. So it was a bad example about that, about how to not label your data set and how to not get lazy on it. So
that is really important. And we also partner with some external company to, if we don't have the right pre-annotated data, because we have so much data collected over the year, but sometimes the data it looks different than what we would like. So we actually partner with an external company sometimes to do that.
Excellent. Thank you, Andrea. We actually are almost done. I think we don't have any more room to questions, and I want you to enjoy your rest of the day. Actually, up there it's still early in the morning, I guess. Or
it's 2 p.m. here.
Oh, 2 p.m. Okay, excellent. So, for our final thoughts, we'd like to give final thoughts, or maybe Mariana would like to address something about some announcements from Fugro. I don't know.
Yeah, for sure.
Feel free to do so.
I can always say something, but I learned a long time ago that when I have somebody smarter than me in the room, I should step down. And that's why Andrea is here. It's quite clear. So I will start by thanking him. It was amazing again. I would like to invite the students and everybody that watch this now live or later to take a look at Fugro. Today, we do have open positions in Brazil to join the innovation team. And it will be a pleasure to have, of course, one of the students of the Federal University with us. So we have those positions open, and it will be a huge pleasure to have you on board. And again, Luis, was a pleasure for us to be here. It's an amazing exchange environment, and for sure we'll be in touch. And if you call us, we'll be here next year again.
Okay, it's my pleasure, and thank you very much to be here at such short notice, and I really appreciate that. And we will keep it in touch. That's for sure.
Thank you so much. Thank you to invite us.
So, okay. All right. So I will wrap up this transmission. It's been a pleasure to be with you guys. And thank you very much. See you next time.
See you next time.
Bye-bye.
Bye-bye.